Hello and welcome to the metadata-driven data warehouse. This is what we're going to cover today. We're going to have an introduction, metadata, building queries, Azure Data Factory, DML from the metadata, and then Power BI. The format of this presentation will ensure that we cover as much of this in-depth topic as possible. Firstly, you'll have an introduction from us. Who are we? My name is Ruth Pearson. I am a support consultant at Simpson Associates. I have been there for nearly 11 years in July. I started off as a Cognos consultant, and now I cover the Microsoft BI stack. I graduated from Manchester Metropolitan University with a BSc Honours in Business Information Technology in 1995. It was a brand new degree then. That's how long it's been around. And interesting fact about me is I played the lead role in Madam Wen in the National Eisteddfod of Wales in 1983. You can sort of guess how old I am from that.
I'm Barney Lawrence. I'm a senior consultant at Simpson Associates. I've had about 15 years of BI experience, mostly in local government, in the NHS and the travel sector. I once asked Itzhak Ben Gan which training day session he was attending at SQL Bits. It was his own training day session, and I was going to it as well.
So I'm Emma Dolling. I'm a senior consultant at Simpson Associates as well. I've got a BSc in applied computing, and I've been working with data on and off for around 15 years. My role at Simpsons is basically working with what we call the blue light sector, so that's policing, ambulance, fire. And one of the interesting facts about me is that my dog thinks every Teams meeting's about him. So I end up with 26 kilos of Springer Spaniel on my knee in most meetings that I have to kind of just cunningly slide to one side.
Okay. Throughout this presentation, we're going to be asking you some questions, mainly to keep it interactive, but also to make sure you're still awake, because I'm aware you've all just had lunch. So to do this, we're going to use a product called Slido. To get access, you can go to the following link. So if you can just QR that code, and then as questions are asked, they will appear in there, and then you can send your responses, and they will automatically appear on the screen. So. Oh. Sorry, apologies. Trying to get this over as fast as I can. Yeah? Is that okay? Cool. So, back to the agenda. What is metadata? A quick search on any generic search engine, and you'll get many definitions of what metadata is. In basic terms, it's just information about data. It's not related to the contents of the tables, the files, or the columns. In terms of data warehouse, it's about the objects themselves, but not just the contents of the database. It's about the servers, the environment, the infrastructure. So the aim of this presentation is that we will show you how to find it, use it, and ultimately make your working life slightly better. The topics that will be discussed in most parts will apply to on-prem, PaaS, and IaaS. So although I'm concentrating mostly on SQL, because it's SQL Bits, it will apply to most databases. So, first question. All right, no, it's not. Okay, sorry. Why is it useful? Instead of writing complex queries to seek database information, we can make use of T-SQL metadata functions to retrieve database information, which will help us save a great time, amount of effort. Metadata can also be extremely useful when trying to monitor your environment, for example. However, this is a whole other topic, and we're not covering this today, although it will be briefly mentioned. So, first question. How often do you use metadata in your role now?
I feel like there should be a drum roll now.
I know. Ooh. The bottom one is getting a bit of action. Impressive. We were actually expecting some feedback from the bottom questions. Some people were going to walk out at that point. Yeah.
Yeah.
Not just wrong, very wrong.
It's offensive.
Yeah. A few times per project, every time I write a script. And so a few times a project, that's good. So you're all a bit aware of it. It's not your constant go-to thing, but you sort of use it every now and again. That's good. So, where can you find it? Within an ETL solution, there are many places you can use metadata that can help you streamline your coding and automate repetitive tasks. I've only highlighted a few on here, but obviously in your data sources, in the analysis, building, loading section, and obviously in the presentation area. They all have metadata, and anywhere that's got metadata means you can use it for your benefit. So let's start at the easiest place in SQL Server Management Studio. In the database, under programmability, under functions, there's a special folder called metadata functions. Now, I've been using SQL Server most of my working life. I didn't really know it was there. I've used the things within there, but didn't actually know about this folder. This exists for on-prem and in Azure. There's some useful ones to note, but I'm sure everybody in here knows about Object ID, especially when you combine it with an if exists. You can check the existence of views, constraints, tables before you delete it or you're trying to create it. So it's not just about data. We can use app versions to get the software version. You can get the language that's currently being used. You can also get the number of rows affected by the last statement. So this brings us on nicely to the next part, system tables and views. Although those functions are useful, there is a host of information stored in various tables, views, and DMVs, or Server Dynamic Management Views. For example, sysdm OS Windows Info returns miscellaneous information, set of useful information about the computer and about the resources available that can be used by SQL Server. I've put a few of the ones that we generally use, used by us. I'm sure you've all got your favorites. Dynamic management views and functions return the server state information that can be used to monitor the health of the server instance, diagnose problems, and tune performance. Again, here are a few of our favorites. I've just given you a description. These are all taken off the Microsoft website, so it's part of it. Next, the information schema. This is another way the SQL Server provides metadata, which helps you try and understand a source database. Here are a few examples that I'm sure you've all used at some point. Views, tables, columns. You'll see these being used in our examples later. And then finally, we have an example of system stored procedures, such as SP help sort, which returns your default coalition. That one I've used quite a lot of time because it generally trips me up. SP databases, it gives you a list of all the databases. And a bit at the bottom there. SP help, something that Barney taught me. Did you know that SP help is linked to a Windows shortcut? So if you highlight a table and hit Alt and F1, it gives you all those details. So this is just done an order line table in the worldwide importers database. That's just 2 button clicks.
Thank you. Who likes SQL? Oh, brilliant. I've chosen the right language. Ruth has shown us where you can get a lot of metadata. I'm going to start showing you how to do things with that beyond looking at it to understand what it's telling you. And I'm going to use SQL because it's SQL bits. It's probably a language you're going to encounter the most, but it's worth remembering you can probably use these techniques anywhere. Anywhere you can get metadata, anywhere you have a language that can concatenate strings or run parameters, you can do this approach. I've done this in C#. I've done this by pasting metadata into Excel and concatenating it into a big query. I've learned better now. So our number one tool is StringAgg. What does StringAgg do? It aggregates strings. It's available in SQL Server 2017 and onwards. If you don't yet have 2017, you can use the technique we used to use to concatenate strings, which I believe is generally called that ugly thing involving 4XML and stuff. If you know, you know. Here's a really simple example. We have a table with the words, "Hello world," from Ruth, Emma, and Barney. And we want to turn that into a sentence. String ag, it's an aggregate function. It says it in the name. If we feed the word and a second parameter, what we want as a spacer in between those individual records, we will get a result out. Quiz time. What will string ag return? Is it 1, 2, 3, 4, 5, 6, 7? Is it "Hello world" from Ruth, Emma, and Barney? Is it "Bob Ward was here"? It's got to be in the source code somewhere, hasn't it? Or is it something else? Let's have a look. We have a #1 lead with "Hello world" from Ruth, Emma, and Barney. The answer is "and Barney, Emma" from "Hello Ruth world." Something else. Why is that? Because someone sneaky put the index on the words. SQL Server, it goes to the table, it finds the words in alphabetical order, and that's the order it's going to put them together. But the good news is we can fix that. We've got our string ag. Unlike most aggregate clauses, there is an extra bit we can add at the end. Within the group, order by word ID. It does exactly what you would expect to do. Within each group, when we're grouping by, it will look at those and it will sequence them. If you're familiar with Power BI or analysis services, where you do that thing where you have one thing as the text display and the other thing as the thing it's ordered by, it's the same, but in SQL. And now we get our hello world in the right order. That's all well and good, but it's not necessarily very useful. So let's delve into one of those metadata tables, information schema columns, the one that I use by far the most. It gives you a list of columns by schema, by table. And we can concatenate the column name for a single table. And out at the bottom, that's what we get. Comma separated, all the lines, as you would expect to see in a SQL statement, as long as you all write all your SQL statements on a single very, very wide line. We don't want that. We probably want some line breaks. We built this for a computer and by a computer, but at some point a human is going to look at this. To fix this, we need to do something in Management Studio first, because Management Studio completely ignores line breaks in query returns by default. So, go to your options, go to results to grid, find, retain, carriage return, live feed on copy and save, and turn it on. Otherwise, you're going to go home, you're going to do this, and you're going to phone me up and say, Barney, it doesn't work. And all I can say is, how did you get my phone number? Now we've got the same query, but we're adding character 13, character 10, carriage return, line break. I can't remember which way around those are supposed to be. A space after the comma to make it nice and readable, and everything will come out in a row. We can copy it from the query grid, and we can use that somewhere in our query writing. We could go a step further, though, and concatenate that list, put a select at the top, we put a from at the top, from at the bottom. We've got that table schema, and we've got the table name inside information schema. We're grouping it all together, And now if we pick that out for, this is from the Worldwide Importers database for the order lines, it's written that select statement for us. You may be thinking, well, that's nice, but I can write a query relatively quickly, and I know if I'm using Management Studio, I can right click and get that select statement. Why would I want to do it this way? And the reason is that query, it's not generating that one select statement, it's generating a select statement for every single table in the database. Even if you're doing that clicking, think how long it would take on a database with 100 tables to generate all 100 select statements. It's still a little bit boring though, because all we're doing is a column name. But start thinking, we've got a string, we can manipulate it. Instead of column name, why don't we have the minimum of the column name? Why don't we have the maximum of the column name? Why don't we do a count distinct of all the different values in the column? Why don't we find the length of the text in the column and work out the maximum length within the column? Why don't we do all of those simultaneously? I had a joke about this being unreadable, but the screen is so big you can probably figure it out. It will be in the slides. I'm not expecting you to digest this. But what this is doing is it's doing all of those simultaneously. And then, because we've got dynamic SQL, it's pivoting them. Instead of having a max row, a min row, we've got a max column, a min column, and so on and so on. This query, I can point it at a SQL database, run it, take the results out of that, run it, and here's that example from order lines. This comes out. I can immediately see how many values there are on the order line. So I know how many rows I've got. I know I've got 227 different stock items. I know the dates start in 2013, they finish in 2016. I know the maximum length of the description field. I've even pulled out the data types. That gives me a very, very quick way to land in a source database and figure out exactly what's going on that table so that I can start making decisions. Having done that, it's over to Emma to talk about how to get it all out.
Yeah, that's one way
in
to
the
put
data.
it.
I should
Okay.
just keep my mouth shut.
So after sort of hearing from Barney and Ruth about getting the information about your data out, now it's time to sort of think about what we're actually doing with the data. So when we're looking at this, we are using Azure Data Factory. It can be used in other orchestration tools such as integration services. The theory is still the same. And what we're going to look at is why we're actually parameterizing this. Why are we actually going to all this effort to do this? So what I've got here is a picture basically that shows how metadata can be used in different parts of the process. For example, we can parameterize data sets, we can parameterize pipeline values, and we can parameterize some other things on there which I can't find. But yeah, so it's about parameterizing things so that it's repeatable, so that you can reuse it and that it can be used more than once. You don't want to be writing or creating hundreds of pipelines to get this data moving so that you can actually get it from source to target. So when we're thinking about this, why do we use them? Where can we use them? Well, we can use the connection parameters so that you don't have to create a connection every single time that you're using these. We can dynamically input file names or even dynamically output table names and append details to output file names. Maybe you want to put a date at the end of a file name when you're looking at these outputs. So to begin with, we need to look at establishing the connection for the link service. Now, everything in Azure Data Factory starts here in the link service. When you parameterize a data source in ADF, the credentials themselves are actually passed at runtime. So there isn't a requirement to constantly create those connections to make sure that connection's there. When creating these connections, it's a good idea to parameterize the secret name and store any credentials in actually in Azure Key Vault, because that is actually a much more secure way to do it. In my demo, it doesn't do that. So then we're looking at about creating parameters. Well, when you create parameters, you need to look for this add dynamic content that is just here underneath the field within Azure Data Factory. Once you've done that, you should be greeted with this screen. Now, this is where you can actually put into your parameters. So you're looking for that little plus sign there so that you can actually input your parameter details, which should come up like this. Now, the most annoying thing about this part is when you actually do that plus sign, there is no cursor here. You have to click in the box. So the amount of times that's kind of, let's just say, made it a slightly frustrating input. Yeah, please change that, Microsoft. So we just want that little cursor to appear in there. So you name your parameter in that box when you've actually clicked in it. So then when we're looking at the parameters, the link service parameters here cover the server instance name, the database name, the username, the password, and the table name. Adding parameters in this way means that we should have a single pipeline using a single data set and a single link service. And again, here, this should be passed in through Key Vault. So what does this look like? So when we're using the parameterized information, we can start to look at moving the data. This activity, this is a basic copy data activity in Azure Data Factory. And this is just basically used to move data from source to target. We can leverage global parameters in each pipeline to move the data. And it's possible to create target tables at this point from your source. There is actually a create table box that you can actually select so that you don't even have to code in your destination tables. This is what your parameters are going to look like underneath there. So in here, we've literally just got the parameters that I've named: server instance S, DB names S, usernames S, password S, and table names S. So what I've done there is just put S on the end so I know it's the source. So it just makes life a lot easier when your naming conventions actually mean something to you. So once connected, we need to think about data movement. And the orchestration tool creates your pipelines. Now, the key thing to remember here is that once the parameters are defined in a pipeline, your pipelines can actually become a pipeline. So you're not recreating multiple pipelines over and over again. And with that, I need to pass back to the guy in orange.
Oh. I'm a little bit less orange than I was.
Visible from space.
Okay, Emma's shown us that dynamic pipeline. And as long as you've, say, got a method of generating a SQL server select statement for every table in the database, you can extract everything from your source system. What do we do next? Because we're talking about a data warehouse, we don't really just want a dump of the source system. We're going to start building a proper next layer, thinking about facts, thinking about dimensions. We can generate this easily. Here's our staging table. It's just been populated. How do we move on? Oh, well, we just do what we did before and concatenate, truncate on the top, stick insert on after that, and that will populate our fact table. Everyone happy? No. Let's get a bit more complicated because we want a better pattern than that. It's going to be slow on a big table for a start. Let's get rid of that truncate, and you're probably more likely going to write a statement like this. We only insert the lines that don't already exist. How would we do this dynamically? It's not actually that hard. We've already seen. Oh, where's my button gone? Insert into, factor order lines. Well, it's quite simple. It's the same as staging order lines. Or I can have a table to tell us where each staging table goes. We've seen how to get a column list. We know the table names, not exist, select star, it's all hard-coded. The only really extra bit we need to think about is this, the business key. How we identify from our source system and our target system what the same roads are. How would I build this? Surprise, surprise, I would use metadata. Because when I build a fact table, I will put an index on the business key. And I will very carefully label that index with something like BK as a prefix so that I can find it. And if I'm going to build that dynamic statement, I can then go into my information schema tables. I can't remember the name of the table, but there is a table that lists all the columns in the index. And it's the same process as before. I'm concatenating. I'm looking for order ID to order ID, order line to order line. It's not that much of a stretch from this list to build that. And I've got my statement. And now I've got an insert-only pattern. That could be all you need. But you can do everything else as well that you would encounter in that load process from staging through to the next layer. If I want to do a delete, it's the same, but backwards. Instead of looking for the things that are in staging, that aren't in the target table, I look for the things that are in the target table that aren't in staging anymore, and delete them. Update. It's a little bit more complicated, but it's the same thing. I need to join the tables. Tables are joining on the business key. I need to build a list of fields to update on. And it's just the field name, except I put it twice with an equals in between. I might want to do some kind of change detection. Choose the pattern of your choice to find out whether there's actually a difference between those rows before the update goes ahead. Again, you're comparing columns which you can concatenate together. If you're writing a merge or upsert, whatever pattern, you're doing all three. And it all comes together, and you've got that there together. So now, a few lists on a thought on the steps you will take towards that next layer. First thing is thinking about getting the data in. We've seen those pipelines. Landing it fast, because until you've got some metadata, you can't do anything without the metadata. So getting that table staged, running it through the pipeline. One of the things I like about Data Factory is you can tick a box and it will create the table if it's not there.
Yay.
So I can just transfer that metadata over. If it reads from SQL Server, magically, my staging table is already there with column names and data types. If you haven't sorted your data types, now is the time to start thinking about sorting your data types. Do you do it implicitly? Do you land everything as text and convert it? Using views, lots of views. I love views. Views are metadata, but they're doubly metadata. Not only are they metadata in the sense that they're a sort of a non-physical thing describing what's on your server, but they create metadata. If my table lands and it's just strings, I can build a view, and I can convert all of those into the right data types, and then when I go to the next layer, the metadata for that view now tells me the right data types to use. So I can sandwich those views in to put things back on course and get that metadata in place. Select into, I use a lot as well. If I've written a big query and I need to build a table to put it into, how do I know the data types for that query? There is a stored procedure that I can feed it into to get the results, but most of the time I just stick into after the select clause, throw it into a table, and look at the results. Management Studio comes back in, and then you right-click on that newly created table, script it out, stick on your identity column. That might be all you need. Or tweak, add your load ID, add your update date, that sort of thing. Build up slowly. We're not expecting you to sit down at your desk tomorrow and never write a hard-coded query again. Begin with a template. Find your first example and handwrite it. Look at it and think, what can I automate? Where's that list of column names? Where's that field join that matches with an index? And then treat metadata as your co-pilot. You steadily automate and you build up a set of reusable script snippets. I have this, I have a query, it builds a column list. It builds an update list. It builds a join. And you can just pick and choose between them until you've got your query without all that tedious typing. And then finally, you get to the really big decision, what you do as your endpoint. At some point, you will be able to dynamically generate almost your entire basics of the transformation layer, all those updates, all those inserts. And you have a question, are you going to dynamically generate that to create the stored procedures that then sit permanently in your database? Or do you end up with one single stored procedure that generates the code, runs the code, and you have this big mysterious data warehouse with just one, it's probably more than one, you need some logging, but one central stored procedure that shifts everything based on the driving tables. Now, when we wrote the agenda, we thought it was a good idea to include Power BI.
You did.
Yeah.
Yeah. And then we forgot we'd included Power BI in the agenda. So what about Power BI, I hear you ask? One day I will get audience participation in one of my sessions. Thank you. Power BI is similar, and it's a good example because we talked about us allowing to do this with different sources and different languages. Here we've got Tabular Editor. Has anyone used Tabular Editor? Oh, it's brilliant. And they're here as a sponsor. Do go and say thank you to them. We can learn things immediately from Tabular Editor. We know Power BI has metadata, because over here, we've got lists of tables and measures and columns, and it's getting it from somewhere. We also know we can do something about that because there's this little box that says advanced scripting. Doesn't it look tempting? Doesn't it look dangerous? And I'm going to quickly tell you what I do when I see that box and I need to make use of it. I go here. Useful script snippets from the Tabular Editor documentation. And usually I take the very first example. I have not gone much further than this. Again, you can go there, you can copy it yourself. But to sum up, what it does is it finds a list of all the columns you've selected on that thing on the left. It loops through them. It builds a measure called sum of that column that sums that column. It sets the data type. It hides the original. I can copy and paste and run this faster than I can create one sum measure. And this can create 100 of the things in 30 seconds. That's a quite efficient speed up, I find. And it's not hard to develop further. I'm not particularly hot on my C#, but last week I needed a count of rows for every table in the model. It didn't take me long to rearrange this to build a count on the tables rather than a sum on the columns. It can go a lot further. If you've visited our Simpson Associate booth yet and seen some of the reporting, Lee, our, I was going to say wizard, but he's actually dressed as a monk for the week. He's done something like this, except it feeds the measure name, the measure, and the details into ChatGPT-3, so it generates a description for every measure in the data model, explaining exactly what it does for you automatically. It's magic. He may be talking about it more at his session tomorrow at 12. Come along, or go and chat to him at the booth. He's the shortest of the 3 monks.
The Welsh monk.
Yes, he's also very Welsh. Over to Ruth.
Right. To try and before I summarise, is there any questions? Is there any questions? Nothing. Wow.
Oh.
Hello. There's a catch box.
Yes, throw the box.
Got a mic in it. You're talking to it.
Yeah,
apparently.
okay. Is it on? Yes. Can you handle delta loads? I can see it works on when you have a complete data set and you have this in an archive. But what about delta loads? Can you handle this? Have you tried it?
In terms of incremental loads?
Yeah, incremental loads, yeah.
Yes, very much. You will need a table to log the information, but at its simplest, it's a log on the destination that lists all your source tables and somewhere to store whatever your last seen value is. Mm-hmm. If you're lucky, you've got a last updated date or a timestamp, and we've seen that pattern to build the select statement. You simply have to build that select statement, and then for that table from the logging table, push in a where clause that says...
So you're adding logic to the incremental load?
Yeah.
Yes, exactly. Yeah. So, and you just need somewhere to store it to push it back.
I think there's one from this gentleman here.
Are you aware of any T-SQL-based templating engine? Because if you build those statements and if they become more complex, the merge statement, creating surrogate keys, whatever else, at one point in time it becomes a mess or string concatenation. And for Python, for PowerShell, there's templating engines, but for T-SQL, I did search many hours and didn't find anything complete.
I have never experimented with things like DBT, BIML, while it was primarily aimed at pipelines, did have the tools to build the SQL statements as well. I would generally, what I would recommend is do things in steps. As you say, don't build that massive complicated thing. Yeah. Have a view that gives you column lists. And then instead of coding the column list, you refer to your little view that gives you the column list for that table.
And plenty of comments.
Yeah. And also that means you can reuse it, because that column list is probably not going to appear in that one statement once.
Yeah.
You can refer to it over and over again.
Yeah.
If anyone's new to Tabularity, it's not called Agnostic anymore, it's called C#.
Oh, they've renamed it since that screenshot.
If they go looking for it, they won't see it.
Thank you. It's now called C# scripting.
Which makes it even scarier.
We saw a little bit of a fact table, but how do you implement complex business ruling in your templating engine?
It depends how complicated. I'm a consultant, I have to say it depends. If it's very regular, you can drive it from tables. I can think of examples where the vendor provided a nice set of documentation, or miraculously, I remember once the source system had foreign keys on it, and we queried them all out to find out where our joins and our key lookups should be. And if it's just a big star schema, you can code that in. And it's almost easier to a point with the metadata, because you're just saying, find all the joins and code in those lookups. If it starts getting custom, as I said, I like views. If I can get away with writing a view, and then treating the view as it's the source and moving on. I will do that. But yes, you're right. There is a point where you have to write SQL, I'm afraid. And maybe that's the point where I was talking about either doing it dynamically or persisting it. Your tools persist it as a starting point, and then you have to pull your sleeves up and do the individual bits that tailor it. It's giving you a leg up rather than building the whole thing.
Okay, thank you.
Any more questions?
Is that it? No? Cool.
Okay.
Last question. Now, how often will you use metadata in the future? I've shown you how easy it is, what's out there.
Whoa. Now that's what we like to see.
Yeah.
Yeah.
That could just be one person, though, couldn't it?
Yeah. No, a rise in numbers is a good thing.
4%. Still not convinced. Brilliant. At least we've imparted some knowledge.
Yeah.
So, driving the metadata, 3 stages. It's a map. Metadata provides you with a map. It shows you where things are and what you can expect to find them and where to find them. Stage 2 is metadata as your co-pilot. And you build together using script snippets, templates, and built-in tools to let metadata take the grunt of the work out of your coding. I'm sure there's people in the audience remember actually the original film, not the new one. 3. Metadata drives your data warehouse. So now metadata takes the wheel. Through collections of metadata, dynamic code, and pipelines, and suitable tooling, large parts of the data warehouse builds itself. Your tasks become one of guiding it and working to develop the code behind the function code that extracts, loads, and transforms your data. So, but wait, there's more. Stage 3 may be all you ever need. You've built your data warehouse, it's easy to maintain and expand, and it will serve you for years to come. But there's a layer beyond that for those of us whose next task is to move on to build the next data warehouse, and the next data warehouse, and the next data warehouse. This is the realm of frameworks, where the full build becomes repeatable. So, what is the metadata-driven data warehouse? At Simpson Associates, it's our ETL framework. So, it's our approach to data quality assurance. ETL procedures can be complex and vary between use cases, which is why you have built standardized input and processes. All solutions are different, but at their core, they have the same underlying mechanisms. And we have worked with hundreds of clients across a range of industries, and our ETL framework was born out of real-world challenges experienced by our services team in collaboration with both technical and business stakeholders. The key points is, having done it the hard way or the long way, we're able to package our lessons learned to benefit our customers. This is continually evolving based on current customer requirements and improvements in the underlying technology. It's time-saving for customers in terms of time, cost, and mitigates risks through quality of assurance. If you want to hear more, go to Stand 8, and I'm sure there'll be more than enough people to talk to you about it there.
The one with the crazy game.
The one with the crazy game. Please play it.
Yeah,
very good fun and very
you should have a go on.
Our feedback form, if you have any feedback about our... Be nice, it's our first time. You can find us at Stand 8, at Community Corner, and this is our Simpson Associates details.